Okay, let's get started. We're going to be talking about multiplying two matrices. And this process is more complicated than when we were just adding two matrices or subtracting two matrices or even just multiplying one matrix by a number. When you multiply two matrices, you need to spread out the effect of, say, the first matrix onto all the parts of the second matrix. And so for that reason, sometimes the matrices don't have to be exactly the same dimensions. Remember, we've talked about dimensions before. The dimensions of the first matrix, this one here is a 1 by 2, and the dimensions of this second matrix are 2 by 2. If we were asked to add these matrices, we wouldn't be allowed to add them because the corresponding entries matched up for the first part, but there's nothing to match up for the second part. However, for multiplying matrices, the dimensions do not have to be exactly the same. There's only two pieces that have to be exactly the same. The number of columns in the in the first matrix, and that's this 2 here, this is the columns, have to match the number of rows in the second matrix, and that's this number here, the number of rows. So since, and we call this the inner dimensions, because if you look how we've written these dimensions here and these dimensions here, this 2 matches up with this 2, and so since those match, then we can multiply these matrices. And so the first thing you want to do before you even attempt to multiply matrices is to make sure that the columns in the first matrix match the rows in the second matrix. And here's the other little trick. The numbers on the outside, this 1 and this 2, that's going to be the dimensions of your answer matrix. So I'm going to have 1 row and 2 columns in my answer matrix. So I'm looking for a number here and a number here. So I sort of said we have to distribute or make sure that this first matrix affects all the parts of this matrix. And the way we do that is by looking at the whole row multiplied by the whole column. That's why these have to match in here. And so what you do, I'm going to just get a different color, is you take the whole row here, this 0 and this 5, and you match it up with this 2 and this 1. So the way you match it up, if you can picture in your head, is you sort of flip this row vertical so that the 0's here and the 5 is here, and then you multiply those two numbers that are next to each other. So I would do 0 times 2, well that's just 0, and then 5 times 1, well that's 5, and then I add those two together. Notice I've put 0 and 5 is 5, and so that's my first answer I put in here. So I've done the first row times the first column, and that's my first answer, my first entry right in here. Well, I'm going to get another color since I have so many to choose from. We're going to do the same thing but with the second column. Still take this row, 0 and 5, and I'm going to match it up with this column now. So again, I can put the 0 here and the 5 here to match them up. So I take this horizontal row and turn it vertical, and then I do the same thing, I multiply. Well, -1 times 0 is 0, 0 times 5 is 0, so that's an easy one. 0 plus 0 is 0. So my answer matrix, this is my answer matrix, it's a 1 by 2. I know that from these here. Okay, this is my answer. And so when I do this, okay, and maybe when we have some more labels, like in the toy manufacturing problem you worked on today, it would make a little bit more sense. But we're always going to be looking for the row times the column. So if we're going to write some reminders, you always want to check the inner dimensions match. Okay, your answer will be the outer dimensions. How about for exclamation points? And then you're going to multiply each row by each column and add the products. The product is the answers when you multiply. So we multiplied 0 times 2 to get 0 and 1 times 5 to get 5, and then we added those products. Excuse me. All right, let's take a look at another example. This here is a 1 by 4, and this is a 4 by 1. So my inner dimensions match. That's good. And my outer dimensions are 1 and a 1. So that means my answer is going to be a 1 by 1 matrix. I'm looking for just one number in here. So again, let me get a different color. If I do this row multiplied by this column, I'm going to match up the first with the first, the second with the second, the third with the third, and the fourth with the fourth. So sometimes I think it's really helpful for people to write those numbers out. So the 3 matches here, the 2 matches there, the 4 matches there, and the 1 matches there. And I'm just going to multiply these. 3 times -2 is -6. 2 times 0, that's plus 0. 4 times 1, that's plus 4. 1 times 0, that's plus 0. So it looks like I just have -6 plus 4, -2. That's my answer. Now, you know how when we're just multiplying regular numbers, for example, if we did 3 times 2, that's 6. And if we switch that order, that's called the commutative property, when you can do things in different orders. 2 times 3, that's also still 6. That property where you can switch the order when you multiply, the commutative property, it does not work for matrices. If you look at this example here, we had a 1 by 4 matrix times a 4 by 1 matrix. Well, what if we switch the order? What if we put this one first? We have a 4 by 1 matrix times a 1 by 4 matrix. Well, we can still multiply them because the inner dimensions still match. But look at our answer matrix. Our answer is going to be a 4 by 4 matrix. We're going to have a huge matrix with 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So 4 by 4, 16 entries in that matrix. Clearly very different than this one. So the order matters when you're multiplying matrices. Okay, means you're going to get different answers, or sometimes it won't even work if you switch the order. Let me show an example where something might not work. If you look at this matrix, this is a 2 by 2 matrix. This matrix is a 1 by 4 matrix. The inner dimensions don't match. No match. If you looked at the rows here, you can see this, right? The 2 and the -1. If we tried to go multiply that by this first column, well, sure, the 2 matches with the 3, but there's no number for the -1 to match with here. There's nothing. It's not even a 0. It's nothing. Okay? So there's no match. So you would say not possible to multiply these. And leave it at that. It's just not possible to multiply them. Let's look at one more example together. Here we have a 2 by 2 matrix, and this is a 2 by 3 matrix, 2 rows and 3 columns. Inner dimensions match, so we can multiply. They do match. Here are my outer dimensions, a 2 by 3. So it looks like our answer is going to be like the second one, 2 rows, 3 columns. We're looking for 6 entries here. Again, let me switch colors. If I start with the first row times the first column, I match them up 2 and -1. So 2 times 1 is 2. -1 times -2 is also 2, so that's going to be 4 there. And then I'm going to do the same row, 2 and -1 times this column. 2 times 5 is 10. Negative 1 times 2 is negative 2. Well, that's going to be 8. 10 subtract 2, or 10 plus a negative 2. 2 and negative 1 times this column. 2 times negative 3 is negative 6, plus 2 times 0 is 0, so we just have negative 6. And since we're being so colorful today, the second row times the first column, so if we cross those off and write in a 1 and a 0, we're multiplying by now. So 1 times 1 is 1, 0 times 2 is 0, so that's just going to be a 1 there. 1 times 5 is 5, 0, well, these are all going to be zeros here on the bottom, right? So that's going to be a 5. And then, because we did this one, and now we're going to do this one times the blue. 1 times negative 3 is negative 3, 0 times 0 is 0. So it's going to be a negative 3 here. Okay? So remember, inner dimensions must match. Outer dimensions give us our answer. This is the 2 by 3 answer matrix. The order matters that you multiply them in. This 2 by 2 times a 2 by 3 matrix works, but if I flip-flop these and tried to do 2 by 3 times a 2 by 2, in this case we couldn't even do it. Okay, it's not that we'd even get a different answer, but we couldn't even do it because the inner dimensions don't match anymore. So some things to look out for, but again, the multiplication, the math part's not hard as long as you keep track of your positives and negatives and just follow that procedure of the row times the column. Row times the column. See you in class.